you all here for the Fursuit electronics panel? Oh shit. Okay, give me like 2 minutes. I was expecting like 2 people. That is so true. Okay.
You're welcome.
How are you all doing? So, welcome to my panel, Adding Useless Electronic Bullshit to Your Fursuit. I think they edited the title a little bit, but basically, my name's Fur. I work for a theme park down in Orlando that has nothing to do with the mouse, and my day job is to put electronic bullshit into costumes. So I have a little bit of experience with electronics specifically as it pertains to fursuiting. So I'm going to kind of try to keep this a little bit high level and like not necessarily get into the whole roots of stuff. We're just going to have a little bit of a discussion about specifically electronics for fursuits and like a big overview of like how to add electronic stuff to your fursuit, what works, what in my opinion doesn't work, a little bit of safety information, stuff just to get you really basic because there's such a like massive amount of stuff to go over. Like even if I had like 5 hours, I couldn't talk about everything that I want to talk about. Also, if he shows up, we're going to be doing a demo. I'm going to be adding a smoke machine to a fursuit head, but if he shows up, if not, we'll just talk about it. Okay, can you guys hear me? I don't want to talk about my... I'm a theater major, okay? I know how to project. Okay, so yeah, like I said, I do a lot of costuming and electronics into costumes specifically. So just so I get a kind of a feel, who here is like actually knows what a soldering iron is? Oh, sweet! So this is like the high-level class. I don't have to go through like, this isn't a wire, this is a circuit board. Okay. So who here knows what a breadboard is? Okay, who here knows what an Arduino is? Who here has heard of NeoPixels? Okay, so I think I've got a little bit of like the level where we're going in. Okay, so I guess I'm going to ask you like a couple little projects. I'm going to make a couple projects, and if you're interested in learning about how those projects are made, or if you want to make something like that, raise your hand so I know kind of what to talk about here. If you want to just add a whole bunch of blinking LEDs to your light, raise your hand. Or to your suit, raise your hand. Okay, if you want to add like a Bluetooth speaker and make it smooth sounds. Okay, who wants to make their fursuit move, like blink, make eyes go? Okay, so a lot of motion control. All right. Who here wants to add like those LCD eyes that everyone has nowadays? Who here wants to learn about that? Sweet. Okay. So I guess I'm going to go really, really basic to start out with, and I'll talk about specific like with suits and stuff. So electronics are basically anything that uses electricity. So there's 3 big things when you have an electronic project to add to your fursuit that you have to take control about. You have to worry about powering it, you have to worry about controlling it, and you have to worry about the output. Those are the 3 things you have to design. And each of them are basic to any project you have, but when you talk about fursuiting, they each have to have their own little tweaks and controls. I'm going to start very, very basic. You know, if you have any electronic project, like this little dog here in the front, he has these eyes that move, they're really cute. You have to have a power source for that. Now, a lot of fursuit electronics operate between like 3 to 12 volts. So a lot of people will just go ahead and get like a cell phone battery pack, or they'll get some AA batteries, or if it's a really small project, they'll use coin cells. A lot of those are really, really easy to come by and really easy to work with. The biggest problem I see with people when they're starting their first project, they're like, oh, I'm going to use this cell phone battery charger, is they plug in a USB, and then they plug the USB into their controller, and then all of a sudden it doesn't work after a minute. Cell phone chargers are really tricky because cell phone chargers, they need to constantly get a charge, they need to constantly put out power or else they'll turn themselves off. Because if you think about a cell phone charger, it's trying to charge a cell phone's full, doesn't take any more power, it'll just shut itself off to protect the battery. So when you're doing that, a lot of people will have to put in like cheaters plugs and some resistors, like constantly draw power. So if you have a cell phone battery charger and you're trying to power your suit, either just have like a little LED that's on all the time so it's constantly drawing power, or there's plenty of like hacks and workarounds about it, but that's the first problem I've always seen when people are trying to do that, is that it stops and they're like, I don't know what's going on. It works for like 30 seconds and then it decides that it's not charging a cell phone and it shuts off. Because again, you're trying to like kind of hack something that's not what it's meant to do, so you've got to trick it a little bit. A lot of people use 9-volt batteries. A lot of people use, just a whole bunch of AA's, rechargeable batteries. They all work fine. Just remember, you have to keep your voltage, to your controller, to your project. Make sure that it's all matching up. A lot of people use 5-volt power supplies for a cell phone into a 5-volt Arduino powering 5-volt NeoPixels. Everything's great. If you're trying to, say, run a 12-volt aquarium pump to make a dragon breathe smoke, you're going to have to worry about level shifting that. And you're going to want to do that at the power stage. The other thing you really have to worry about power, especially in a fursuit, is making it easy to remove. This is the biggest problem I see when people have fursuits and they're trying to power their suit. They'll put it inside a pouch inside their suit right against their skin. You guys have seen all the Galaxy Notes that like to explode and all that stuff. Imagine you go and you buy a $3 1500 milliamp battery charger from China. That cell phone, those batteries probably aren't the highest quality, and the charging circuit probably doesn't have all the protections in it. So it's very, very likely, it's super rare, but it's definitely within the realm of possibility that if you're running your fursuit, powering all these lights, you're drawing a lot of current, that battery may very well overheat. So I always say when you're doing this, we do this in like professional costuming too, make the battery pack outside of your body and make it easy to detach and put breakaways on the cable at the power source. That way, if you feel it getting hot, or if someone sees it getting hot, you can just pull it off and drop it. That's probably the only real safety issue you're going to have to worry about at these lower voltages. Like, if you get, if you have a wire that shocks you, 5 volts is not going to do too much damage. 5 volts, like, 2 amps, really not going to do much. But if the battery pack starts to get hot, especially these big ones that are drawing a lot of current, especially if you're using the cell phone chargers, you're pulling a lot more current than someone you pulse sometimes, you might have a little bit of a problem. But, like I said, just keep it apart from you, try to keep
Close
it
the door.
something where you can safely break it away, especially when you're designing, you're doing the design from the ground up. Like, please don't keep it like in a body pack inside of you, or keep it inside your head. Like, you can separate your power source from your controller. So, like, the next thing you have to worry about is, like, you got your power, your controller itself is what's going to control all your outputs. A lot of people bring up things like Arduinos, they'll bring up Raspberry Pis, like even little tiny Windows computers, but you don't really need a microcontroller to do things like controlling lights. If all you want to do is have a fursuit with eyes that glow, you can you can just have a power switch, and that's your control. It takes your power, you switch controller power to go to your lights, and turns it on and off. That's all you need to do. And for a lot of suits, LED eyes are a great little way to add some stuff. Or you can add LED claws. Just have a way to control it. Just the power switch. It's super simple. That technically counts as a control, and that's all you need. There's plenty of suits I work for at my day job where it's literally just a power switch. Turn them on and off. They run on their own. No other controllers. A lot of people use Arduinos nowadays. Arduino's like this basic prototyping microcontroller. You can code it in C. There's so much guides out there, so many help. Basically, it's a whole bunch of those little switches, and you control the logic.
Thing he's talking
and you
about?
tell when switches come on, which switches come off.
What's
when
that
you
device
listen
he's
to button
talking
presses,
about?
when you listen to different,
How to connect your power source.
information.
I understand, but it was a little like a microcontroller.
And there's so much you can do
Things
with it. I highly recommend you just go buy the Arduino starter kit. I think it's like $40 on Adafruit, and you can really learn and you
I
can
understand.
control a lot of things very simply, like LED lights, little servo controllers, and it's all documented. It's a great way to learn. I'm not going to really dive too deep into that. I'll usually at this point I'll start going into Arduino coding, but it's really simple to learn. You guys seem to know what you're Another thing is Raspberry Pis. They're a little bit more complicated. Raspberry Pis are actually like a full-fledged computer on about the size of a credit card, but they also have the same thing. They have GPIO pins, which are what lets you control lights, control servos. It's a little bit different, and there's a whole lot more you can do. But if you're definitely interested in doing a lot of things, I would look into a Raspberry Pi to be your starting point there. A lot of people have asked me do I do an Arduino or do a Raspberry Pi for my project? My usual goal is describe your project. I want it to light up and breathe smoke and make wings go. And if you can describe it with one and, use an Arduino. If you have more than that, use a Raspberry Pi. An Arduino is very simple at doing specific things again and again. A Raspberry Pi has a lot more RAM, a lot more ability to control stuff. So if you have one and, an Arduino can probably do it. But if you have several ands in here, like you want to have something that does a lot of stuff, you're going to probably want to go to a Raspberry Pi or some larger prototyping system. And then, so you have your power, you have your controller, and then you have the things that you're controlling. And this is the fun part. This is what your Fursuit actually interacts with doing stuff. This is the LED lights. This is the servo controllers. This is your smoke machines. This is your speakers. You have to worry, with each individual component, you have to worry about powering that component. You have to worry about controlling that component. But if you think about it through all the way, it's pretty simple. Most LED lights will be perfectly happy at 5 volts, 3 volts, 9 volts, whatever your project is running on. Most servos run at 5 volts, but you can also step up and down to those. You can buy products specifically for this, specifically for your project at whatever voltage you're running at. Same thing with speakers or anything. It's really easy to try to get your power to that working right. Now, to have your controller control your items, you're going to have to figure out how to program your controller to talk to it correctly. There's libraries that you basically download and you put on your controller, and you use that to interface with basically anything. If you're using LED lights, any type of smart LED lights, there's libraries to control it. If you're using any type of servo, there's libraries to help you control that for both Arduino, Raspberry Pi, whatever it is. There's guides, there's ways to help you out there. It's pretty simple. Again, I usually get deeper into this, but you guys seem to know what you're doing, and Google exists. It's pretty easy to figure out how to interface your controller to your components. So LEDs are like the most common thing that people use when they want to put fursuits in. I've seen so many people that want to have an array of LEDs in their chest and have it light up in new patterns, or have their eyes glow certain colors. My favorite was one person did a fairy wand that went from their heart and a string of LEDs down to the fairy wand and then shot out at the end. That's a really cool idea. There's lots of things you can do with LEDs, and the cool thing about fursuits and LEDs is that fur diffuses it so nicely. You put an LED underneath fur and it's just this nice even glow for a few inches all the way around. Basically everyone will use smart LEDs. They won't have a controller directly controlling the LEDs. They'll have the biggest and most common thing are neopixels. They're a type of LED. They come in a whole bunch of form factors, but mostly they're strips or circles or pads of LEDs. And basically each component, each LED has its own little tiny chip inside of it. And that little chip actually controls what color the LEDs are going to. So when you're talking to your controller, all you have to do is tell your controller, I want this pixel to be red or this one to be blue. And you can run a single wire down your whole strip of LEDs. And it's really, really easy to program and really, really easy to make cool patterns and cool effects. There's lots of documentation, lots of writing. You got a question?
Nope.
Okay, never mind. Kind of looked like it. Really easy to make these big patterns that everyone's looking for. And I really recommend you look into it. They're very well documented. Adafruit sells them. They're called NeoPixels, but you can find generic versions of them. WS2182 LEDs or something. 2811, thank you. It's pretty easy to find them, and there's loads of documentation. There's loads of pre-programmed stuff to make for them. That's kind of another thing. Is when you're thinking oh, I want to make this, you don't really have to go all the way down to bare code and then rebuild it yourself. There's so many people who have example codes, who have pre-made things that you can just kind of copy and paste, and all of a sudden you have this working project. It's not necessarily exactly control every single step of the way by you, but it's doing what you want it to. So you can find all these guides and then slowly build up from that. a lot of people have those LED or LCD screens in their eyes, and they look around, they blink and stuff. Hey, like that guy right there. Yeah.
This is visual aid.
Yeah, bring it right here. I'm gonna assume these are the Adafruit eyes.
Oh yeah.
Yeah. So these are actually this is like kind of an example, I guess I'll show off. These are
Can you stand up with it?
yeah, totally.
Yeah.
Yeah. These so this fellow with the small jaw problem. Awesome. So this is a cool project by a guy named Phil Burgess. He actually works for Adafruit. He made this whole control on himself. Behind each of these eyes is a little tiny 1.5-inch LCD screen. And controlling this is a thing called a teensy. It's like a really souped-up version of an Arduino. And basically, I'm going to assume cell phone battery bank or...
500 milliamp LiPo.
Okay, yes.
Hanging right below, you can show that too right now.
Okay, yeah, so like I said, like right here, like I say, you got your battery, you've got your power source right here, it's the raw lithium polymer battery. It connects directly to the controller, which I'm going to assume is...
Up in the
Yeah.
microcontroller's up
Yeah.
in the top.
There's a microcontroller up in here, and the microcontroller is connected by wire to these two to these two LCD panels. And like as you can see, it's a really fucking cool effect. And it's super basic, and like you go onto Adafruit.com and you'll see the glowing eyes with teensy tutorial, and basically all you have to do is download the parts, and it'll give you step by step, show you how to solder wires together, give you a real good introduction. You don't really need to know every single bit of this code. And you can get this up and running. There's even ways to, for you to put your own eyes on it and still have it control without really knowing the deep down code. So you don't need to go ahead and like learn C. You don't need to start off, you don't have to go all the way down to bare metal and say like, oh, if I want to make an LED blink a certain color, I have to learn C and then learn how to compile and then learn this and this. No, it's really, really simple. You can go as deep as you want, but you don't really have to for every project. Learn what you need to do, and you'll slowly gather more and more skill sets that you'll be able to apply to other projects.
Are they in C?
Arduino technically is in C. It's like a little tiny bastardized version that Arduino uses, but it's really easy to go from the Arduino IDE to just learning C and using your own microcontroller. Okay, question.
I just had a quick. Are you aware of any eyes like that that are made with transflective displays that don't have a backlight?
So this is a specific project that was made with these parts in mind, but there are definitely those out there. I'm working on like my own port that uses a Raspberry Pi instead of an Arduino to control the eyes, and that can be ported to any type of display. I actually stole. Samsung had a example that they did a few years ago of a new cell phone technology that was like totally transparent and flexible and shit. And they made a few like store model displays to show off at conventions. They never did anything after that. And then I just found one on eBay, for like $30, and I bought it. I want to say I stole it, but it was like, it says like proprietary Samsung electronics on it and everything. It's awesome. But it's like same thing. It's a flexible display. It has no backlight. So like, and I'm not saying like, oh, look at me, but like you can, like I am currently porting that over to make something like that. So there's maybe not be a project specifically that exists with step by step, guiding your hand the whole way, but there's definitely ways to like do that kind of stuff. And I'm sure that given enough time, this will like happen to the point where it's easy to happen. But like right now, those flexible like displays, like even just like non-reflective displays that are just like raw LCD with no backlight are really hard to come by right now.
Yeah, I was thinking of like something with like a high-speed e-ink with some sort of a reflective surface on the back, so you could have an eye that changes, but it doesn't have to be lit up, because some characters that doesn't make sense for.
Oh yeah, definitely. Like these, the backlight you can just turn off and it's just straight reflective.
Yeah. Okay.
But it's also on black because they intend to have a backlight on it. But there are definitely displays you can get, and it's definitely trial and error. You can find different displays, try to put stuff in. You can definitely try to find different components, and you're able to like just experiment with this. Like components are cheap. Like I think the most expensive part of this, are these the OLED ones or the?
They're the OLEDs.
Yeah, the OLEDs. Those are the most expensive part. They're like $40 a piece, but you can like, if you want to get, you know, if you can start off with like LCD cell phone screens that they make, and they're like 15 a piece. The teensy's $20. You can use that wherever the hell you want. The battery's probably like 10, 15. Like, this is really not that expensive to get into, and most everything you buy is going to be reusable, and most of the stuff you break is going to be cheap. Most stuff. I've broken a couple $100. I've made the magic smoke happen on a couple $100 pieces before, and that's not fun.
What color?
Hmm?
What color was the smoke?
Blue, definitely. For some reason, it's always blue. Yeah, octane. And it smells amazing.
Oh.
For days.
Yep. So yeah, so I guess if you've never done electronics before, you're gonna want to start building your tool bench, and there's gonna be a few items that you're gonna want to get when you're starting to like make Fursuit electronics. There's a few basic items that everyone's gonna want to get. The first biggest thing, and this is what everyone has, is a nice soldering iron. Now, this is the only time where I say, you know, don't scamp out on it. Do not go to Harbor Freight and buy their $4 soldering iron. And if your uncle tries to give you his hand-me-down soldering gun that looks like an actual gun and has like a big ass tip on it, say thanks, but that's actually for plumbers. I'm doing this for electronics. Go to just
You can get a nice Hako for about $100 on Amazon.
yeah. Hako is a great brand for the makers. They're bright, beautiful blue colors, and they're really cute.
Yeah, they look like a Toys R Us.
They look like a toy, but they're fantastic. They're from Finland? Somewhere, but they're really great products. I personally use Wagner tools.
Wagner.
Yeah. I've got one that was made in 1978.
The
that
old
still
Wagners
works.
are good. Beware
Yeah.
of the new ones.
The new ones are a little bit flaky, but seriously, just price point. If you see any soldering iron that's about $30, you're gonna have a good. You know, that's about the minimum you're gonna want to buy. Buy a nice soldering stand. If it has that little plastic flippy thing that comes with it, throw that thing away. Those should be illegal. Buy like a nice spring stand for it. They're $4.
Check cleaner's always useful.
Yeah.
The sponge is crap.
Yeah, and a sponge is good. Get us, tip cleaner. Get a nice little kit. Really do not skip out on it, because if you buy the cheap stuff, you're going to hate soldering. You're going to realize, and you're going to not want to get into this hobby. The next thing you're going to want to get is just a nice little assortment of just little components. Like, you're going to be buying project pieces, but you're going to want to have like a nice little library of pieces on your own, because you're going to be breaking some stuff, and things are cheap. Yeah, you're going to want to buy a set of resistors, set of capacitors, maybe some buttons, switches, a bunch of breadboards, prototyping equipment. I'm not going to go through every single thing.
Lots of connectors.
Yeah, buy connectors, buy cables, buy a hookup wire, like spool set. They're like $20. Yeah.
If you have a Radio Shack
yeah.
going out of business,
Yeah, there's plenty
you
of.
can ask them for their whole case.
Yeah. I've seen them sell those. Those are awesome. But yeah, like you can go online and there's like, the electronics beginner kit. They'll probably be about $100. I really recommend you get one of those just to start out on a good footing. And then you're going to want to start making your first project. So when you're going through the design phase, I do it in a few different steps. The first thing I do is I write out what I want the end product to look like. I don't think about anything specifically like what controller I'm going to use. I'm not going to think about the actual components themselves. I'm like, for example, last week I made a raptor, and I wanted that raptor to roar when its mouth opened. And I wanted to have little hairs on the back of its head stand up after the roar, or like when it was roaring. And that's all I said. I didn't think, okay, I want to have like a switch here to control it. I want to do any of that yet. And then I start working that backwards from the way I was talking earlier. So I start thinking about my outputs. Like for example, I want it to roar when the mouth opens. So I'm going to need a speaker. I'm going to need some way for it to detect when that mouth opens, and then with the back of the hairs, I'm going to have to figure out some way for that to move up. So I'm like, okay, so I want a speaker for that. I want to have, you know, a switch. I ended up using a servo to do force feedback. And then back of the head, you're going to want to have little servos, which are basically little motors with self sensors and actually. I'll talk about that in a moment. At that point, then I said, okay, so I have a speaker, I have a couple switches, and I have a few servos. What can I use to control all that at once? So I went back to my original thing. I wanted to roar, and the spikes on the back of his head to move up. That's only one and, so I went with an Arduino. I went and bought, pulled off my shelf, and pulled off an Arduino Uno and started prototyping this. You got a little shield that makes sound when you connect to an Arduino. You connect that in, and then it's just, at that point, it's all little connect blocks with your code. So you say, okay, I write up my code and really simplifying it. When this button is pressed, make this sound play and make these servos move to this position, then wait, and then have the servos move back down. That's literally all the code is. It turned into like 30 lines. It took me about half an hour. I didn't know how to do some of it, so I went on Google and I figured it out. But it's super easy to prototype that. And then the last part you have to think about is power. Your controller's going to want power, your individual speakers are going to want power, and your individual servers are going to want power, so you're going to have to worry about powering it. So I did the same thing as this guy. I just got a nice beefy LiPo battery, ran through a charging circuit. You have to learn how to wire up specifically from your power source to all your components, but each component you get is going to have a spec sheet, and you're going to have to learn how to do that specifically. I can't tell you, how to wire up, specific lights for everything. But it's pretty easy to do, and there's so many guides and helpful guides outside of here. Maybe not necessarily towards specific to Fursuit, but just electronics in general to help you with powering your components. The next step is, now that I figured out, okay, I'm going to use these components, I'm going to use this controller, I'm going to use this power source. I physically, before I even put it into a head, I sat down on my bench and I physically started to wire it up using a breadboard. A breadboard lets you connect wires really temporarily without having to solder them together. And I just started, connecting wires. Okay, power goes to here, the power goes to these components, the Arduino connects to here, this connects to this, and that connects to this. It took me about probably 3 hours to prototype it, and it's really fun, just plugging in wires and figuring out what happens. You sit there with your laptop, you get really angry, you get upset, then you stop for a second, then you go Googling some stuff, then you look at cat videos, and then you come back to your project. And after a while, you'll get something and it's moving, and you're like, Eureka! And it's your first project. Congratulations, you did something, and you made something that wasn't there before, and then you always feel good. Yeah, what's up, buddy?
Quick question. With digital electronics getting faster and faster, what are the speed limits when you're using a breadboard? Do you have to worry about, keeping your microcontrollers below a certain megahertz speed or something before you introduce glitches and prototype things?
Okay, so basically your microcontroller, when you're breadboarding stuff, your microcontroller lives on its own. The microcontroller, depending on which one you buy, Arduinos usually run 16 megahertz, but you can buy ones that run 8 or 3. Raspberry Pis run at whatever the hell they want to do. You don't really worry about specifically the controller itself, say under overvoltaging or overclocking, because usually within your prototyping board, like the Arduino itself, the Arduino isn't the microcontroller. The Arduino has a microcontroller in it, and it has a bunch of circuitry to help you interface with that. So when you're talking about specifically overloading that circuit, a lot of the problems is you'll write too much code for it to store in its memory. But there's different ways to go around that, and controllers are getting faster and faster and faster, but for a lot of stuff you're doing with Fursuit, you really don't need any of that gas. These eyes, they run on a TC that runs at 32 megahertz or something, not really all that powerful. And a lot of your Fursuit projects are going to be very basic when it comes to very, very basic when it comes to processor. You're not going to be doing things connecting into Wi-Fi, quarantine the latest Game of Thrones, and then explain it through a projector out of your mouth. I mean, if you want to, feel free to. That's actually a really cool idea. If someone puts a projector out of a fursuit, I want credit.
Cool.
Yeah, it's like really simple. Like, you know, most of the controller projects you're getting are going to be pretty simple as far as those are concerned. I completely forgot what I was talking about. So,
Breadboards.
oh yeah, breadboards. Breadboards, you know, you're going to sit here and you're going to build out on your table before you install it in your fursuit. And then I guess this is kind of the meat of what, when it comes to specifically electronics for fursuiting. There's a few things that you do specifically with fursuiting that you don't really worry about with other types of projects. For example, if you're building a little tiny robot at home or you're building like a car that moves, you don't really worry too much about cable management on the inside. Like, you'll worry a bit, but with fursuits, everything's connected to a human body. The human body stretches and flexes around, and you've got to be really, really careful about running wires through your body in spots where it stretches. Yeah, what's up?
And the human body sweats.
Yeah, that's definitely another concern. But yeah, the human body will sweat, the human body gets hot, the human body moves and flexes. The biggest thing I want to always just drive in when I do these panels is when you are designing your suit, you're putting your electronic components in your suit, worry way too much about your cable management. Try to think of it like the human body. Have a specific vein of wires going somewhere and then have it spread out where it can, but don't try to just have everything go in a giant mess everywhere. Have your battery controller, you know, go in a loom somewhere to from your battery to your controller. If you're doing, like, for example, gloves with claws in them, you know, and you'll have your battery pack, say, somewhere here, run a bunch of wires up here and then split it out down here. Don't have all your wires just loose all the way going up here. The biggest thing, most specifically, is your elbow. The elbow is the spot of your body where it stretches the most, so make sure you always have some cable relief here. Like, when you're designing it, make it so it's not necessarily all the way tight when you're at your most flex spot, because you're going to be doing this a lot, and if this moves a lot, you're going to pop out wires, and there's going to be some problems. Sweat is another big thing. Yeah, what's up?
I was just going to say I've got to remake my claws sometime because I did not do that in my hands.
Yeah.
So I popped up wires in some of my controls.
Yeah, see, learn from him. He made the mistake. You don't have to now. What's up, buddy?
The other thing is that wireless modules are getting a lot easier to use nowadays, so the other option is to actually have different parts standalone that they're able to back the
Yep.
and wireless.
Yeah, so wireless is actually a really interesting technology that's coming out very quickly, especially like if you have an Arduino project, you can now you can move things around wirelessly with really little. You don't really have to know too much about the specifics of wireless to do it. Like, you don't have to dive deep into figuring out how to make things talk to each other. There's places where it just kind of works. And it's very interesting, especially if you're trying to get to places like, for example, your head. Your head will pop off, so you don't necessarily always want wires running to it. So you can have like a wireless controller in your chest talking to the electronics in your head. The thing is, power doesn't transmit wirelessly, so you're going to have to think about a secondary power source to control just those components. And then the wireless receiver, the transceivers are also going to have to be powered, but it's definitely something doable, and I recommend looking into it. Yeah, what's up?
Experience with that, actually.
Yeah.
I had a friend that had a quad suit and has no vision, so built a camera system vision. It's built off the ones that you have backup cameras in the car, and it was working fine. He shot as soon as she took it on the floor. The wireless signals way too interference.
Yep.
Everything else went in the con. She was blind the entire time, and it was terrible. Which is why I built this camera system that's wired, that uses like a little video goggle glasses that came out like a couple, like 5-10 years ago.
Those things are kind of cool.
It's like really low res, but I wanted to avoid that problem, so I have really long wires that are give a lot of because it's a lot more reliable.
Yep.
And the human body is a lot of water that will block out radio signals like nothing else.
Yep. So one of the things that happens,
keep that in mind.
yeah, one of the things that is happening is that, especially if you're doing high bandwidth things like wireless video,
Yes.
that requires a lot of wireless bandwidth. You might run into those problems, especially down here with everyone and their mother having a cell phone and everyone wants to, like periscope things. So you're having like, so much wireless spectrum being eaten up. But it's pretty easy, especially if you're doing something like just controlling a couple of bytes. Those are usually a lot stronger, but yeah, try to make the wireless distance as small as possible. It's definitely one of the considerations you have to say when you're building your suit. Put your receiver at the bottom of your chin and have the transmitter on your chest. Like that, just that little bit of distance is usually enough for a wireless controller to talk to each other. Bluetooth, if you're having, like I try to avoid Bluetooth or try to avoid any of like the commercial wireless things. Just what's up?
So the one that I'm using the normal wireless things such as OneSLAN,
Yep.
is all of a sudden you use your cell phone as a
Controller.
Yep. Yeah, that was actually gonna be something I was about to talk
Oh,
about. No, it's fine, man. Dude, you guys know where we're going with this.
find an example then.
Oh, sweet, awesome. This is like a show and tell too. I'm gonna like stop talking about like 10 minutes and we're gonna have show and tell. Yeah, what's up, buddy?
Yes, I make a prototype of a wireless controller. I put all the stuff, animatronic in my head, and all the controller on in the end.
Yeah.
So I use a RF24, and so far it's working perfectly.
Yeah.
And you can choose a lot of, you can speak to 2, 3, 4, I think maximum 7 different parts. So what I will do is control the head, light in the other part, so no wire anyway.
Yeah, that's definitely a cool way to think about it. Like, especially, the RF20 or the RF24s. XB makes a little module that's really great for like wireless communication. There's definitely a lot of cool platforms right now, and it's something you're just gonna have to like Google and find out yourself. I really do not have that much experience with wireless. The only thing that I've done, another fun work story is we built a Raptor currently at one of the theme parks down in Orlando. You can go meet the Raptor, and the Raptor roars and has it growls and it'll talk to you and it interacts with you. A little bit behind the scenes of that is that the way that it roars and the way that it talks to you is that there's an operator standing kind of out of sight on an iPad, and it can actually control when it roars, when it barks, and all that stuff. And it talks to the performer inside of the suit. What we did was we just had Wi-Fi in an iPad and an iPhone app, and the iPhone actually goes out of the headphone jack. One side of the earbud goes to the performer, so the performer knows what's about to happen. The other one goes to the speaker system inside of the suit, so it roars. Super low tech kind of thing. It was like we just had these on hand. We built this really quickly, and it works. So
just don't mix them up.
Don't FaceTime. Don't make any phone calls.
Another neat thing you can do is if you have a ham license, you can get access to some of the bands that are likely to be a lot less used.
Yeah, ham licenses are actually something that are really fun to get, and they're really kind of easy.
They're doing a panel on it later today. You can actually get one, or tomorrow. Like.
Yeah, thank you for the plug. Yeah, go to that panel. That sounds like fun. I might go do that one. What?
I know they do the Fox, but
Yeah, he says after the Fox hunt, it's unfortunately during the dance competition, but they're actually letting you do that. You can do the chest and get your license right there.
So, I'm going to comment about the interference issue.
Yep.
The two main ways of doing it. The video centers tend to be very narrow spectrum, so if you get interference visual, basically screwed.
Yeah.
Things like the NRS or wireless LAN will match their spread spectrum. So anyone else who doesn't use the same code, they will play noise. So they can get through. They degrade gracefully, channels will apply to use a certain format. It's going to take an awful lot to block it.
spread spectrum is different, yes. Especially over these kinds of distances.
Yeah, you guys seem to know a whole lot more about RF than I do, so if you guys have any questions, yell at those guys. Okay. Yeah, what's up?
So, when you're putting LEDs in your suit,
Yep.
what guidelines do you use to determine how large your battery needs to be?
Okay, so, alright, with LEDs, each LED has something called a maximum current and a maximum, and a forward voltage. Most LEDs, they'll pull about 20 milliamps of current. Most RGB LEDs are, 3 LEDs in one, so you usually do the math about 60 milliamps per LED and put them all at full brightness. Now, most of the times you won't want them all at full brightness, especially if you have a nice long strip of them, because that is really incredibly bright.
And it gets hot.
And it gets super hot, and it's really annoying.
Especially blue.
Yeah. So so you might want to say specifically within your code, limit it to say 50% brightness. If you're doing gamma correction, that's like if you have 3 LED ons, they're going to draw maybe like 30 milliamps. So you start doing that math. So like for example, let's say you have 100 single LED lights at 20 milliamps. 20 times 100, 2,000 milliamps. That's 2 amps of power. Yeah, 2 amps of power specific for that. At that point, you're going to think, okay, so if they're on at full brightness, it's going to draw 2 amps of power. If you want to pull it at full brightness for 1 hour, you're going to need 2 amp hours or 2,000 milliamp hours to power it. You're probably not going to do that, so you kind of just got to think about now your performance-wise, like, is it just going to be like a raindrop? Is it not going to pull that much power? Maybe I can get by with a 1,500 milliamp hour battery to last me for, a fursuiting run. There's, and you just have to kind of do that math, figure it out, more or less. Most battery, like cell phone battery packs, will be like 4,000 milliamp hours. So if you have something like the example I just said, you mostly be fine. If you have a bigger power supply, you're gonna have to worry about like, more power means more current, or it doesn't mean more current. It just means you're gonna want to have some if you're drawing more power, you're gonna want to have thicker cables. You're gonna have to worry about that. But it's definitely just find all your components, add it all up to figure out what your maximum draw is and how long you want to run out. There's lots of math to figure it out, but it's all online. It's all super simple.
You can test tools for just measuring that correctly. Say you have a raindrop pattern. Say I just ran this pattern for an hour. How much power will draw?
Yeah. So basically, it's pretty simple to do. You just if you have a pattern already going, you can grab a tool called a multimeter, and you can figure out just what current it's pulling at that point. And then you figure out what the current that's pulling, multiply that over the time that you want it to run, and figure out the size of the battery that you need for that. Yeah, what's up?
The studio element, first one you mentioned, of course, you have the milliamps or whatever you do. Don't skip out on your cables with the high quality cable, because as you bend them, the cheaper cables, they'll start to break in the middle of the current capacity goes down. Don't skip out on connectors, USB connectors, you keep pushing in, the resistance goes up, you get that stuff out. The other one actually is that nowadays you can buy on eBay USB charge monitors. They're a little LCD screen that lets you know how well your cell phone is charging. The new ones have a counter on them that tells you how many milliampere hours have been through a specific reset button. They're about $10 or $20. It means that if you've got a dynamic load, you don't have to be watching a slow stuff and trying to do the integration in your head and all that. You just look at the number, you run it for an hour and see how many milliamps. So that's what you look out for on eBay.
Yeah, I actually grabbed one for my cell phone like the other day.
Yeah, but the one that actually has the counter on it as well. Because the old ones just gave you a current and a voltage.
Yeah. Yeah. What's up, Ben?
I was gonna say, just chip in. One good power source would be this is not an alternate route. 18650 batteries, commonly used. They're high grade. They can hold up to 4,000 milliamps.
Yep. Yeah, there's
30 amp draw current max. The only thing is battery safety.
Always wire in there.
Yeah, definitely when you get into those like super high current batteries, like I said, you're gonna have to really worry about the cabling. You're gonna have to really get really quality cable for that. You're gonna have to get like nice connectors. Never buy counterfeit JST connectors. They're on eBay for like 10 cents. Never buy those. Just buy the legitimate ones. buy good quality stuff. There's definitely some places you can skimp out on, but really just try to keep your parts like legitimate quality. Don't necessarily buy like the eBay China special, get it in a month. Buy from like, you know, reputable dealers. You're gonna get better quality. You're not gonna have problems down the road when things start breaking and you don't know why, because it looks like it's perfectly fine, but on the inside all the cables snap.
Prototype is pretty easy, but kind of special though.
Yeah, you can definitely prototype, and like, you know, you'll get lucky with it. And like, I've got a giant bin of stuff I bought on eBay because I thought it was cool and only $1. And then I get it like 2 months later. I'm like, why did I buy this? Yeah.
Well, the thing is, like, we're kind of worried about like batteries exploding inside your Fursuit.
Yeah.
That'd be a horrible way to go.
Yeah, so that's kind of why I was saying earlier, like, the biggest safety issue is, like, especially with, like, even if you buy good brand batteries, they will have problems, and they may, you know, they may start to heat up. That's why I say keep the battery pack off of your suit so you can remove it easily. What's up? Okay.
My dad in his muscle, he has his CPU fans.
Yep.
He actually, they slot right in.
Yep.
But he has to replace them every season because the humidity inside the suit will make them eventually burn out. They're meant ball bearing fans.
Yep. So humidity inside of a suit is definitely something you need to consider, especially if you have something around your mouth, because your mouth is constantly breathing out. Like,
Just for him, you might have him look at PC fans. Look at Nocta, they use a sealed ball bearing.
That's what it
Really
really fast.
A Nocta fan? Wow. You tend to seal them.
it might not be necessarily the humidity. How's he powering?
He's kind of.
Okay, because with PC fans, a lot of them operate at like 12 volt.
Yeah.
And if you underpower them, they wear out really quickly.
Yeah. PC fans are 12 volt.
So sometimes that's when I see people like with fan coolers and they run them off a 9 volt battery, I'm like, it breaks every 2 cons. That's why. PWM is different. That's how like that's how PCs slow their fans down. That's voltage causes problems. Sweet. Okay, so I kind of ran out of things I was gonna say, and it looks like my dragon hasn't shown up yet. So I guess either we can do show and tell if you guys have something you want to see, or if you have a specific project you're thinking of, like you can bounce the ideas off of me.
Just for fun, I was going to comment earlier, you know, running those things high is probably stronger than what we use in
The controller. Okay, this is complete fucking tangent, but this is the one thing. Okay, everyone brings up the whole, oh, my TI calculator is more powerful than what we sent to the moon. Oh, my cell phone is more powerful than what we sent to the moon. Yes, the controller on the computer, the computer on the fucking Apollo missions was very, very low power. One, because they didn't have the ability to send power to it, and two, because the majority of the calculations were done on Earth and sent to the fucking Apollo computer. So the big brains were here, and those were powerful. Yes, the modern computer is definitely more powerful than that, but it's not like we sent the fucking people to the moon on a fucking TI calculator. We didn't fucking do that. We sent them with the calculator, and we fucking streamed the information to them. There was you can run Netflix on you can run Netflix on your fucking Raspberry Pi, but you can't render the fucking dragons from Game of Thrones on them. No, you have to have somewhere else. Okay, so thank you.
Yes.
Yes! Thank you, I love that. Okay, but yes.
Sorry. Sorry.
Go ahead.
No, I was just gonna talk about an example, that's all.
Yeah, come on here, show off this thing. I've been looking at this thing, it's fucking awesome.
Okay, so well, the only thing I wanted to talk about actually was collaborative control. So if those of you who bring out your cell phones, you will find an access. So my name is SyncX, Sinus Cardinal, the signal processing geek. Some of you will know what that means. If you bring out your cell phone and look for wireless LAN access points, you will find an access point called SyncX Tail. That's actually a microcontroller sitting in my tail. It's a captive DNS server. You go to any FQDN, it'll resolve to the control IP, the control page, and you can change flight colors. So, just talking about some of the things that you can do with a suit, you can have people link in and control things. It's all the WeMOS modules, which are Node MCU, so these Internet of Things modules. Yeah. And nice thing, you can program them with Arduino, so they're very easy to mess around with. Classes, basically, off the shelf. Yeah. Anyway, so if you, I think someone's already connected to it.
Trying to.
Anyway, so okay. Well, of course, the problem is now everyone's hammering the portal access point. And by the way, if anyone wants to try to hack into it, don't bother. Not only does it not have a file system, it doesn't even have an operating system. you can't even access it. You can't write to anything from the website. So, anyway, that.
This is cool shit.
The classes also have their own access point as well, so I can control both sides from my cell phone. So.
Yeah, so that's definitely a cool project. Like I said, like there's like.
Sorry. Yeah, Eigen is the name of the.
Oh no. Oh, glitches! I love those.
I've got a spare.
That's fine. Here, you can have. Here, you want one of those?
What happens if we get a phone call while
Oh,
you're
yeah, you can do it, yeah.
Like as a controller?
Yeah.
So a lot of cell phones, like Wi-Fi and cellular, are actually two different things. I think the only one left is Sprint, like my phone, so you can't actually get a call and use internet. But Wi-Fi and cellular are usually two different technologies, and they'll still talk. And like, for example, his tail, it's kind of like that Apollo analogy I just made. There's a controller inside of his tail, and there's a controller inside of his eyes that actually does the talking to the LEDs themselves. Your cell phone, if it disconnects, it's just talking to the controller, so it just loses that communication. And inside there's code that says, oh, I've lost I'm not being talked to by a cell phone. I'm gonna just run this code on my own. I fucking love that.
So I can change the expressions from my cell phone. There's a similar web page. So I can change it to Now, this is all placeholder for a suit I'm building, but that one would actually have an Android device strapped to the forearm, and also controllers in the fingers, because of course these WeMOS modules, which are about $5 each, so they're cheaper than an Arduino.
Yep.
Of course, they can also send GET requests as well. If you put up if you put your phone in tethered mode, you can then actually have it go out on the internet and fetch things with text commands. So yes. Anyway, it means you can start doing collaborative stuff both with yourself as well as with other suits in the area and around the world and whatever. Your suit is now part of the internet.
Oh man, yeah, that's
You are the Internet of Things.
Yeah, remember I was talking about low bandwidth? Because this is such low bandwidth, and wireless LAN has good ways of managing low bandwidth in radio harsh environments. It will take an awful lot of interference to stop this from working. No, this is 2.4. This is 802.11b. It will talk to M, but by default it comes up with D.
Those WeMOS modules are really fun to play with.
Yes.
The Internet of Things is like completely kind of different. Like, I'm not gonna lie, I think you're the first person I've seen use like the WeMOS module, like on a suit in that way.
I'm not sure I'd go to the extent of calling this thing a suit. It's a tail master plus their glasses.
I mean, having
and a lab coat.
Yeah, needing like an open network to have other people connect. I've
Yeah.
never seen that happen before. The closest thing was I made a couple of suits probably about 2 years ago at this point. They had hearts in their chest, and they tried to connect to each other, and depending on signal strength, the hearts would get louder.
I think Geek sell shirts that do that as well.
Yeah, I kind of stole their idea.
I have one.
They kind of work, sort of.
Yeah.
Unless you've got 3 people in the same place.
Yeah, there's too much interference. They would work if there wasn't
So
more than
much
50.
The
love!
narrow band is the problem. If they do
Yeah.
spread spectrum modules, it would have all worked.
But that's expensive. You can sell cheap stuff. Sweet. Okay, yeah, what's up?
Yeah, so I was just curious if anybody had heard about like somebody using or assembling a first-person vision system from a drone into a fursuit head as like a means of like being able to see a lot better without having like eye holes or whatever, something like that, where you have a whole
That's what I
head.
just was talking about earlier.
So there's
I
certain-
have a
oh, you-
system built
okay.
like that, yes.
Yeah. Okay.
I have a little bullet camera.
Yeah.
Just makes it go like a motorcycle dash or something like
Yeah.
that. Because I want everything to be a wired connection. And it plugs in as direct video input into a pair of really old video glasses that used to hook up to like your iPod or something to like, it's like a movie theater in your eyes when you're on a plane. It's not like that at all.
Right.
It's like the lowest res, it's like 200 by 300 or so pixels, it's very tiny little screens, very low res, but it does the trick. And let me tell you, it is the trippiest thing ever, having the bullet point camera, somewhere else, and you have to remember your perspective to the camera is so much different as you're moving around. So I did practices around the house. I blindfold myself, and I hold it, and I just practice going through it, and it's crazy how far away things feel, yet then you bump into them anyway, because it has slight fisheye warp on it, because I wanted a wider range of vision. I wanted wider angles, so I didn't hit anything from the side. It is a challenge, let me tell you. It is a very much challenge. And then the video glasses, they don't work for more than maybe like an hour.
Yeah.
But that wasn't all a built-in like system. All it was just like a mini TV. I just wanted to go with something that was pre-established. However, now I'm looking to upgrade it into stuff. Right now, everything with the drones is becoming so much better for video control systems that are being put into cameras. So that idea is being revisited again, and it's going to be so much better because I wanted something super low profile. You have your really, really nice, like Sony $900, awesome things. They come out to here, the giant chunks of things on your face. It's not going to work in a suit. It works, the technology is there, but getting all the components to work together and doing it really cheaply is definitely a big challenge that I ran into. But it's totally possible, totally works.
Technology is getting so much cheaper, like every day. Like, if I did this panel 2 years ago and they're like, oh, I want to do a vision thing, I feel like you just don't bother with it.
Yeah, exactly.
Like, now it's crazy.
Was there anything you needed to do for like low light? I know I see the cameras, they have the LED, the infrared LEDs that you can buy. Was that necessary, or did they work in low lighting?
The camera was like, it's super, super basic. I'm sure if you get something cool, it'd be nicer. But it has a backlight, like on the actual screen that I'm looking at. It is just like looking at like tiny TV monitor. It also is really weird. It has a left and right like offset to it, but it's one input. What it does is it splits it in the appropriate way. And you can actually slightly adjust if you want the screen to be projected a little bit closer or further together to match like your eyes or your vision a little better. Because if something's really, really close to your eyes, it's one singular screen, it's gonna be a lot harder to like stare at. That's why I figured I'd go with something with already kind of built-in system to kind of work with all that. Right, but I would love to just like, just do a bunch of little custom like that with it. But I made sure that it was a camera that would work in low light. Yeah, it doesn't have any sensors to really adjust it very well. And it was because it was it was an experiment, just to disprove the concept. Exactly, just to see that it would be possible. I would love to upgrade to something much nicer with the camera side because you're going to so many different environments. When you're at a con, you're going walkouts, you're at night going to dance, it's going to change a lot. And all you would have to do is just find a camera that suits your needs a little bit better. And then, of course, finding a place to hide it somewhere. You probably want it on your head somewhere just because you want to move your head and your camera moving with it. But we were kind of making a bunch of fun stuff. Like, what if we made like a Sam Serrano costume with a visor, and it has a lot of like controllers that would determine, fan speed, and it would display everything on the inside of a flexible screen. We were just like going crazy with ideas because for the first time, it's accessible to do in your home. It's not special Hollywood effects anymore. It's like here and now, and it's so exciting. But yeah, totally. If you want something that will detect and automatically change the brightness or the focus of the camera, just get a camera that can do that. The video glasses are a completely separate component that don't have anything to do with that control.
How's the latency on that, by the way?
Oh, that was the other thing I was really worried about, especially with wireless, was the connection. If I was doing anything that was live streaming, everything that I was looking into was going to be like, I was really afraid of that delay. But if it's direct input with the cable, it was to the T, like it was live time. And that's awesome. The video glasses have maybe a tiny bit of delay rendering it, but not enough to cause me any issues. It's just something you have to like work around or work with, and just lots and lots of practice. But yeah, that is a good point.
Well, the issue you're going to get with the drone senders nowadays,
Yes.
they send for a long distance. They're at 5-point-something gigahertz, the new ones, which are blocked by the body by about another order of magnitude more than 2.4 gigahertz. The other thing is that if you buy the ones out of China, check the power level, because in a lot of jurisdictions they run at a power level that's getting.
Yeah.
The final one is that you need to be very careful with the antennas, because again, those antennas are designed, they're usually some funny clover leaf on the something or other. They're designed to have nothing in the near field for about at least 30 to 50 centimeters. If you're going to have a body anywhere in the near field of those antennas, you're going to find the gain on them drops off a cliff. So even though it can go 1 or 2 kilometers, it might not get through the body. So just be careful about that. And in narrowband too, so refer to previous design.
What's up, buddy?
Well, you said earlier how you're talking about the dragon. Unfortunately, they didn't show, but I was wondering about issues with how you go about doing the smoke machine of the dragon, and if it would, like, would you have to worry about setting off fire detectors?
Okay, so
Detectors are usually a paper mix.
So basically what we were going to do is I was going to show and tell, and my buddy has a dragon head, kind of similar to that, except a little bit wider. And I was going to show how you can combine household materials to make something really cool. So I was going to do my nose smoke machine that I've made a few times. Basically what... Yeah, you want to smoke? I don't have the parts because they're in the box with the head. But basically, one of the things that came out recently are, all the e-cigarettes and stuff. And the cool thing about it is that they've miniaturized, smoke coils. So you can now have a really, really small source to make a bit of smoke. So if you want to say you have a dragon that breathes smoke out of its nose, it's really easy to take an e-cigarette, and I wish I had one because I could show it. You just pop off.
I got one.
And good. Well, unless you want me to rip it apart and shove a. No, it's okay, man. It's really kind of easy, and I've got guides online if you want to look up. But small aquarium pumps, which just pump a little bit of air. Basically, all you do is you just kind of reverse the way an e-cigarette is supposed to go, and just blow air through the smoke coil, and then you have a very easily controllable puff of smoke to come out of a nose. It's very quickly to vaporize and really quick to make it. It's a cool effect. It's people sometimes think it's a lot easier than it would have been a few years ago with mini fog machine and servo controllers and all that stuff. But it's a fun little thing to make at home, and I've got the guide online. It's on fursjunk.com. And you can find it under the tutorial section. I think. I just changed websites. I forgot if it's still there or not. It'll be there eventually. But yeah, so that's finding little things. Yeah, buddy.
I was just going to chip in. Out of the two things you can use for fog, vegetable glycerin is the best.
Yep, vegetable glycerin is what I always say if you're using that, especially with e-cigarettes, because it really quickly disperses, and you're not going to have anyone have any adverse health reactions compared to if you're trying to use the cheap dollar store Halloween smoke machines.
And it's also thicker smoke.
Yeah, it's also thicker smoke, and it looks a lot whiter than anything else I've seen. Yeah.
I have a specific project I'm going to be doing.
Sweet.
I plan on making a sweet quad suit if anyone knows anything about Pokemon. And I want the ribbons to
My
flow
friend tried to do
back.
that actually.
What?
My friend tried to do that. He told me
Really?
he wanted the ribbons. He didn't know what he was doing. He was poor guy. But he went to Radio Shack, bought these giant fans like this, and the battery packs were this big, and they weighed 5-10 pounds.
Oh,
I'm like, what are you doing? Anyway, but you figure out how to do that.
Yeah.
I want to hear. I want to see.
So the easiest way to do that is to call your local wizard and just have them enchant some magic. No.
though, so that's.
I've seen that. Okay, yeah, the ribbons are full like that. So, there's about
Just run really quick.
there's 1,000 like guides online on how to make animatronic tails. Most of them involve just like bike wire and a couple servos pulling back and forth. You could probably like find one of those guides and then just like kind of hack it together to make the, instead of like controlling the tail, have it control those things.
Would it be
Yeah,
able
don't
to
use fans.
stick forward though and not like hang down like a tail does?
Yeah, you can. So what you do is you just get a big. What I would do is I'd find like some kind of stiff foam, like core,
Yeah.
like something like flexi foam or something that's a little bit stiffer.
Yeah.
And then like just shape that the way I want to do, and then I would use like the super simple way would be put a servo at the base and then just run like a bike line up and down over it, and then as the servo pulls either way, it'll flow left or right. But it'll try to like if you have the servo at its neutral position, have like most of the structure be on that core to be in the position or wherever way you want that tail or that ribbon to kind of flow.
So we'll kind of do this if you ever see it animated, so it's like.
Yeah, at that point you'd have probably got to give a couple different little servos in there, but that's definitely something you can do, and it's easy to experiment. Like, you know, buy some like foam core and like experiment. Like, you're not going to be out too much money. It's pretty fun to play with.
It's gonna be great.
Yeah, and servos are kind of noisy, but like if you're building a quad suit, you can like put foam around it and stuff.
Yeah.
Yeah.
Another recommendation is instead of doing bike cables, when you check out RC airplane supplies, they usually have the cables that they use to control like the aileron and stuff. They're a lot lighter and they're a lot cheaper.
Yeah.
You know, to cut them in sections, if you want, then the cable pulls, you can probably bend in multiple spots.
Yeah.
Different types.
Yeah.
They also hook up directly to servos anyway.
There's plenty of different ways to like try to do that. That would be my recommendation is to just look, try to see how people are doing tails and kind of just gut it for your purposes. You don't have to go all the way to the ground up when you're rebuilding stuff. Oh, this is a cool thing. I'm gonna steal this idea. And then like another thing I always recommend is when you're done, post lots of pictures of you building it, show how you're making it, let other people see what you're doing, and you're gonna there's a community. People will like help you with this, they'll give you suggestions, you can give them suggestions, they'll be like, this is awesome, this sucks, do this. And it's really fun. Like I'm on a Telegram group where I'm just like talking about like the projects I do, people talk about the projects they do, we give each other support, and it's fun because everyone loves each other. And like we have cool things, and I've actually gotten some really cool suggestions for stuff I do. Like one my big project I was doing for this con are actually these little ear tags that we're going to be passing out to fursuiters, and these are cattle tracking tags with NFC chips in them, and I hacked them together. So right now, if you have an NFC phone, like for example, this one actually brings up a Twitter page. Like you just have to scan it, and like it goes straight to your Twitter. So like if you're in a fursuit and you want someone to follow your Twitter, you just point them here, scan their phone, or if they have an iPhone, just flip it up, QR code or something like that. So, what? If you would like to get these, I'm going to be selling them for not too much at firstjunk.com. Here's the shameless plug. I've got business cards and stickers if you want to get But yeah, and like that's the thing, like cool little projects like that. If you know me, I've been talking these like fursuit zippers that I've been 3D printing and making with those. Like, you know, cool little props. Like there's stuff to build upon everything. Does anyone else have like a project that you either want to show off or just talk about?
I'm going to be looking the headless.
Awesome.
But rabbits and hares have the splits in the nose and they separate to smell at 3 different locations. So how would I get the machines to work?
Okay, so yeah, so there's little tiny mini servo motors that can fit basically anywhere, and kind of same thing. I literally just so you have your nose and it splits into like 3 little parts. You have that made out of foam, like a little spring and a little cable pulling and a servo pulls that back. It'll pull it back just enough to make the nose come back, and then the spring will naturally want to make it go back to its neutral position.
And then I have another project, which is a 12-year project.
Oh boy.
Along with my brother Greg, which he is getting right now his doctorate in robotics.
Congrats.
And we're going to be having some trouble with this one because we are going to be having a combination of a hair, but it's going to be cyberpunk power armor foam.
Okay. Hell yeah.
So it's just, I'm thinking if I could know what the Telegram thing is on there, I could put progress on there.
Yeah, Telegram is called, I want to say just like the electric fursuits. I think is all it is. It's on the Fursuit directory. Yeah. I guess the only thing that I would say if you're looking for something like a bunch of screens like that, you want to do like clustering. You want to have each display have its own little computer controlling it, and then each of those computers talk to like a central computer. Don't try to have like one thing controlling all the displays.
That's what I was gonna figure.
Yeah, but I mean that sounds pretty simple, and then you can break it up into parts. But yeah, it's a 12-year project. God bless you. I do not have that.
Well, the thing is, this thing's gonna be a monster, and I want it to be like actual power. I'm gonna have it slide. It's gonna have like extra strength, so I can lift heavier things. It's gonna end up being 9 feet tall.
Yeah, there sounds like a lot of cool things in there. And like I said, just if you're working on projecting it out, like just split it down into bits, like bits that you can work on its own, and then working about connecting them all together. But that sounds really awesome. I want to see something. I definitely want to see that in a couple years.
A lot of my friends, almost all my friends are artists.
Yep.
On the LCD screens, to go with the flavor of the cyberpunk worlds, is have their advertisement on the LCD screens.
Yeah,
That's awesome.
yeah. Sweet. That's totally doable, and especially like, you know, as time goes on, cooler and cooler things are going to happen. It's going to become easier and easier. They're going to make a lot more like end-user friendly applications for these things. Like for example, the NeoPixels. Like a few years ago, you'd have to figure out how to address all these all these LEDs on your own. You have to get like your own controllers for everything. And then the NeoPixels came out. Now all of a sudden, it's just like 3 lines of code, and you can make these really cool things. It's going to get simpler and simpler now. So it's a really cool time to just find all these technologies and kind of just put them in your suit. So we got like 10 minutes left. Does anyone else have any like projects they want to share, or they want to talk about things they want to make? Get my opinion as someone who works at a theme park. Oh, yeah.
I was going to comment about the LCD screen.
Yeah.
Is that depending on how much you've got the time versus money balance, it may be worth just getting low-end or older cell phones or tablets and using those as the screens, because then you've got all the power, you've got the control behind it. They can be free running if they lose communication, or they can all communicate. So that may be an easy way to say self.
Sweet. Okay, in the back first. Yeah, what's up?
Do you know where to get EL wire in bulk?
Oh, sweet. EL wire in bulk. Okay. EL wire is this awesome, cool technology. It's basically. Yeah, EL wire is awesome. I've used it very, very rarely, so I don't really like have that much experience on it. But it's basically like you treat like flexible fluorescent line. It's really cool. It's like this either wire or a tape or a grid, and it just all lights up on its like controls on its own. You need to power it with an inverter, and the 2 things about the inverter that people don't tell you is that 1, it makes noise. 2, they'll tell you there's a maximum length, but what they don't tell you is there's also a minimum length. So you don't want it. You want to have it within that right amount of zone to power it, because if you have it too short, it's going to explode. If you have it too long, it's going to be really dim. One of those is worse than the other. Yeah, but to find it in bulk,
Which one is it? They were.
I forget what it's called. I want to say it's Ring Planet. I've never heard of that one. He's there to vouch for it. Vegas. What is it? Vegas Light Source, I believe. They actually produce it in house. And it's really like high quality stuff. A little bit more expensive than say buying from China, but you get what you pay for with that kind of stuff. Yeah. Oh, sorry. No, yeah. It depends on the inverter. You're gonna have to find that specifically, but it's usually something around like 6 to 12 inches. If you need to have like some like for between eyebrows, like just get a couple foils and cover it in black tape. Do you have a question? Oh.
Fantastic.
Yeah. L-wire, L-tape is really cool. I do not have that much experience with it, so like I can't answer any really big questions about that. But like they you can interface with them the same with like everything else. They have an inverter to power it, but other than that, you can treat them kind of like a little fixture. Yeah.
Oh yeah, we came in like 30 minutes late, missed the intro. Were you the one that did the eyes in that head?
I did not do that. That was by a guy named Phil Burgess.
Oh, okay.
Yes.
I can never say his name. I call him. I just say Burger.
The original project, there's an open source project on Adafruit's website.
I remember seeing the head on a Telegram page a while back.
Yep.
I never had to really get a take a look at it.
So like I assembled it and did a custom image on them and added like a few little modified functions, but it's just branched off of that open source project on Adafruit. Yeah. There's a list of materials there in the source code.
What was that website again?
Adafruit. Yep. ADA fruit.
Yeah. Okay, so I'm gonna just give you a few like resources to look into. If you're looking to buy stuff, there's two websites that most people would recommend. Adafruit, ADA Fruit. They sell a lot of stuff to teach you. They have 4 or 5 people that they pay basically just to build projects and build cool things, and then they don't sell you like it completely done. They sell you the kit to make it yourself. You learn a whole lot along the way. Everyone says that they're a little bit pricey, but you really do get what you pay for there. Sparkfun.com is another place, kind of the same idea. They're a little bit cheaper than Adafruit, but they also kind of don't have as much in terms of guides and helps. If you're looking for places to just buy components, DigiKey and Mouser are the 2 big places that people usually go, and they're the places where you can go buy like 500 resistors for $2.
Yeah.
And it's fantastic. I basically get a package from DigiKey every other day.
Could you spell those?
DGR?
Yeah, DigiKey, D-I-G-I-K-E-Y.
Okay.
Mouser, M-O-U-S-E-R.
M-O-U-S.
Package from DigiKey every other day.
Yeah,
What do you enjoy it?
I thought I put an A.
Yeah. No, I
Yes,
paid.
okay, say where you live.
Oh boy, I
Yeah,
paid
what's
$250 for UPS or USPS shipping.
I know where a couple other packages are.
Pay that much. Yeah, Adafruit manufactures everything in-house in New York. SparkFun is
Uncanny Eyes.
Colorado.
If you look
LA?
up like
Sparkfun's Colorado.
Colorado.
It was a fun thing to build, definitely.
Oh, okay. Yeah, it's a little bit south, it'd be a bit of a cruise, but you could actually.
Yeah, they're fucking cheap. But yeah,
Actual magazine.
yes. Yeah, there's plenty of other places you can buy from. Yeah.
If you're buying the things like these LEDs or the Windows modules or whatever, and you want to buy them in bulk and really cheap, and you really know what you're doing, you can go to AliExpress, which is an offshoot of the Chinese Alibaba site. Please do not go there if you don't know what you're doing.
Yeah.
AliExpress.
Oh, yeah.
Because there are plenty of scammers out there.
The thing I've said this about AliExpress and Alibaba and stuff. Go with a friend.
Yes.
Like seriously, go to that website, and this is literally just a good idea for anything. Look it up, see if you can find it, and if you find something that you like, send the link to someone. Say, hey, do you think this is legitimate or not? Because AliExpress is basically connecting you to the Chinese manufacturers directly, and a lot of people. Funny story. I needed a whole bunch of SD cards, and they all said, and the Chinese manufacturer, like it said big words, 16 gigabyte SD cards on top, and then the very bottom is like, oh, not actually 16 gigabyte, just printed with 16 gigabyte on top. They're actually 16 megabyte cards.
Oh wow!
That was a fun day.
I bet.
But yeah, so then that happens all the time. Like I got duped, people get duped all the time. It's
The other thing is pay for the expensive shipping because the free one is untracked.
never shows up.
So I always use DHL on it because the shipping is more than the components. The whole order is still about 2 to 3 times cheaper than Barcode.
Yep. Totally. Yeah. The only reason why I really try to hawk on Fruit is that because they do a lot of
Yes, training.
training, lots of learning stuff. Like that's how they make their stuff. And especially some of the stuff that there's one thing that I always have to get from Adafruit. It's there's silicone wire, and this is great for fursuits. Like fursuits is usually most cable is PVC coated, and it's kind of not terribly flexible. Adafruit sells silicone coated wire in a whole bunch of different colors, and it's super flexible. It's like wet spaghetti, but it carries current just the same as everything else, and it's super flexible for like fursuiting projects, and it's super easy to, and it's super high temperature, so you can't burn it with your soldering iron. I literally cannot find another place to find these. Yeah.
Hobby King sells the silicone wire.
And
with
he tells
the
me
high current multi-strand in the middle.
Yeah.
Because the other thing about running cables with fursuits, if you have corrosive sweat like I do, the PVC will harden and it will start to crack after a while. So the silicone doesn't.
I have just one more quick one. Is there anything like better than squirrel? Is there anything better than squirrel cage fans for like pushing a lot of air quietly? Sort of like linear air accelerator type thing, like a cockroach heart, or like.
There are, but they get stupid expensive.
Right.
Yeah, like if you're trying to push a whole lot of air, like there's some options. I've never really looked into them too much, so I can't really help you all that much there. But like there's I saw one that's basically like a mini jet engine.
Yeah, I've seen them.
And it says pushes something like 300 cubic feet like a second or something. I'm like, if you want to cool off.
You're talking about electric ducted fans at that point that you use in model aircraft.
Yeah, so yeah, there's like definitely there's ways around it. I just don't know that much, so I can't really help you out. Okay, so we've got like 5 minutes left in this panel. I'm just gonna say one like last thing with like design philosophy. And I kind of stole this like line from Philby, but like, do you remember in the 90s when CGI was like the new thing, and like every like think the TV show Reboot, and like you look back at that, and everything was so gaudy colors, and everything was flashy, and you think, oh, that was just because it was bad CGI. I mean, that can be kind of part of it, but the reason is because it was a new technology. They're trying to show off as much as they can. And they're not really taking into account like the artistic merit of it. Like they're trying to throw as much into it as possible. And I see that a lot with fursuits nowadays. Is like they're going to try to embed as many lights as possible in their suit. They're trying to embed as much, like, just try and show off these lights on their own. Being like, oh, here's my suit that just happens to have a billion lights in it. And they don't really think about necessarily like what those lights do to help create with the craft of the character or to help show off. Like for example, like adding LED eyes to that head, that adds a lot to the creativity. But if you put just the like glass eyes in there, that head still stands on its own. You're not necessarily doing it just to show off LEDs or show off servo motors or show off the fact that your dragon breathes smoke or the fact that it has fireworks coming out of its head. So, and I feel that like right now we're at the point where electronics in fursuits is getting to be to the point where everyone's like, oh, look what I can do. And we're about to get to that point where people are starting to like really just build it into the suit as another part of the suit, not necessarily just as an exhibition of the technology. And I feel that that is something that everyone really, like when you're building your suit, when you're designing it, think about that a little bit when you're putting your suit together. And the stuff we're going to come up with in the next couple of years is going to be absolutely fantastic. And like I've run this panel for like the past 4 years, and like this is the most I've ever seen people in it. Everyone's getting interested in it. I feel that that's really fucking amazing. And I feel that like there's so much guys out there and there's so many people interested in it that the next few years in fursuits and electronics in fursuits and the interactivity is just going to be really phenomenal. So thank you guys for coming to this. And I really want to see what y'all do. Thank you. That being said, if you're interested in the kind of stuff I do, come take a card. They're absolutely wonderful. I made them myself out of construction paper.
A mini jet engine.